A very good afternoon to one and all. Today we are going to study our fifth lab program. So let us understand the problem statement of a lab. Design, develop and implement a program in C for the following stack applications. Again, in this experiment, we need to do two programs. First program in that is evaluation of suffix expression with single digit operands and operators plus, minus, multiplication, division, remainder and exponential. And second part of the program asks us to solve Tower of Hanoi problem with n disks. So this is the problem statement. So as we have studied in our classes, suffix expression is also known as a postfix expression. In our previous lab program, we have studied the advantage of converting your infix expression to a postfix expression, because when we evaluate postfix expression, we will not be having any parenthesis and there is no concept of traversing the given expression multiple times. So in today's example, let us understand what is postfix expression. And again, we have studied this in our previous lab program. A postfix expression can be defined as the operand 1, operand 2 followed by operator. Operator will be placed at the end and operands will be placed before the operator. Such expressions are known as a postfix expressions. The expressions written in postfix form are evaluated faster compared to infix notation, as parentheses are not required in a postfix expression. Before we jump into implementation, let us understand the algorithm to implement a given problem statement. First, we need to create a stack which will helps us to store operands, and after that scan the given expression and perform the following operation on every scanned element. When you will scan your element, suppose the scanned element is a number, then we need to push that particular number or value or operand into a stack. Suppose the scanned element is operator, then first we need to pop operands for the operator from stack. Here exactly we will perform pop operation and we need to perform pop operation twice, because whenever we want to perform our binary operators, we required two operands. And the trick to solve this given problem is, whenever you perform first pop operation, you need to initialize the value to a operand 2. When you perform your second pop operation, the whatever value you will get from pop function, you need to assign that value to a operand 1. With the help of both operand 1 and operand 2, we need to perform the scanned operator. After that, whatever result we will get, again we need to push back the resultant value into a stack. This procedure we need to continue until and unless we reach to the end of your given expression. After that, whatever element is present in your stack, that is the final answer for your given postfix expression. So let us understand this algorithm by taking one simple example and how things will work. This is only part A I am talking. In fifth program we are having A and B. Currently we are discussing only about part A. So your given postfix expression is 5 3 plus 6 2 division, multiplication, 3 5 multiplication and then plus operator. This is our given postfix expression. As per algorithm, we have already studied that we need to traverse our given postfix expression, and in each trace we will extract one element from a given expression. And always tracing should be or processing should be from left to right. In our first iteration, we will extract 5 from a given expression, and as we know, suppose the extracted or fetched character is value or operand. In that case, we need to directly push that value to a stack. Prior to this, our stack is empty. Now I want to push the element 5 to a stack, hence I am increasing the top value, and currently top is pointing to 0, and I have pushed the element 5 to the 0th index. After that, our next element is 3, and again it is the operand, so I need to push that, and prior to that I need to increase the value of top by 1, and then I am initializing 3 to that particular location. After that, if you observe, our scanned character is now operator. Whenever the scanned character is operator, we need to perform 2 pop operations on stack. When I perform first pop operation, it will return 3 and the top value will be decremented by 1. And as I have clearly stated, when you perform first pop operation and whatever value you will get from that function, that should be assigned to operand 2. Hence, now the value of operand 2 is 3. Again, one more time we need to perform pop operation, and by this time the popped value is 5. As I have already stated while explaining algorithm, when you perform your second pop operation, whatever value you will receive, you need to initialize that value to a operand 1. Then perform your arithmetic addition, that is your scanned operator is plus. We need to perform this operation on operand 1 plus operand 2. Yes, we have already have values for operand 1 and operand 2, they are 5 and 3 respectively. Hence, 5 plus 3 is equal to 8. After that, we have stated once you evaluate the expression, whatever result you will get, you need to push that to a stack. Again, if you observe my next operation, I am pushing the resultant of our previous sub expression, that is nothing but 8. And now again stack contains the resultant value 8. After that, our next character is value, hence we need to push that to a stack, and 6 is placed above 8. Our next scanned character is 2. Again it is a value. So we need to perform push operation. Now 2 is placed above 6. After that, our scanned operator is division. Currently, our stack contains values 2, 6, 8. And now, our scanned character is not a value, it is an operator. If it is operator, we need to perform two pop operations. So when I perform first pop operation, it returns 2 and the value is initialized to operand 2. Similarly, when we perform another pop operation, the returned value is 6 and that value is assigned to operand 1. Now I am performing division operation on operand 1 and operand 2. The values of operand 1 and operand 2 are 6 and 2 respectively. Hence, 6 divided by 2 is equal to 3. Again, the resultant value need to be pushed back to a stack. So hence, I am pushing the resultant value 3 to a stack. Now, stack contains elements 3 and 8. After that, if you observe, again, our scanned character is operator. This time, our scanned operator is multiplication. So hence, again perform pop operation. Now, after performing first pop operation, it returns the value 3. Similarly, when I perform another pop operation, it will return 8. 3 will be assigned to operand 2, 8 will be assigned to operand 1. So now we need to perform our multiplication operation on operand 1 and operand 2. So the value of operand 1 is 8 into operand value is 3. So resultant value is 24. As we know, after evaluating our sub expression, the resultant value should be pushed back to a stack. Hence, I am pushing 24 back to a stack. Now our scanned character is 3. So directly push that 3 to a stack. And after that, our scanned character is 5. Now push 5 to a stack. Now stack contains 5, 3, 24. After that, our scanned character is multiplication. So hence perform our first pop operation, it will return 5 and that will be assigned to operand 2. And second time when we perform pop operation, it will return 3, that will be assigned to operand 1. And our scanned character is multiplication operator. Hence perform multiplication operation on operand 1 and operand 2. The value of operand 1 is 3 and the value of operand 2 is 5. When we perform multiplication operation on these two, the resultant value is 15. Again, after evaluating our sub expression, we need to push back the resultant value to a stack. So now, after pushing 15 to the stack, stack contains 15 and 24 as elements. Finally, if you observe, again our scanned character is plus operator. In this case, again we need to perform pop operation. When we perform first pop operation, it will return 15 and that will be assigned to operand 2. And second time when I perform pop operation, it will return 24 and that value will be assigned to operand 1. After that, I am performing the addition operation on operand 1 and operand 2, and as we know, the value of operand 1 is 24 and the value of operand 2 is 15. So when we perform the addition operation on these two, the resultant value will be 39. Again we need to push back this value to a stack. Now after pushing 39 to a stack, the only element which is present in your stack is 39. Now if you go back to your expression is reached to the end. So once our expression is reached to the end, then we need to pop out the element or the value present in your stack. So when I perform pop operation, it will return 39, and this is the final answer for your given postfix expression. So I hope you understood this diagram and also tracing of this particular given expression. So with this concept, let us understand the implementation of our given problem statement. So yes, we need a stack of 20, that is nothing but expression which we will hold top equal to -1. I will come back to push and pop later, and again we have discussed these functions enough times. First let us start with main function, character s of 20. Here I am using this array to hold the postfix expression, integer x comma I comma y. Using printf, I am displaying message to end user to enter evaluation of postfix, that is heading I am displaying to a end user. Again with the help of printf function, I am asking end user to enter the postfix expression. When expression is entered by end user, I am reading the expression with the help of getS function, and S is nothing but array which will hold the entered postfix expression. After that, for I equal to 0, and we need to perform this loop until and unless it reaches to the end of the expression. Hence I am calculating length of a given expression, so that I need to perform our for loop so many times, and each time the value of I will be increased by 1. For the first time, when we have extract our first character with the help of our string and with the index value I, that is nothing but s of I, that is nothing but first character present in our given postfix expression. So it is checking is digit. Is digit is the built-in function that is defined inside ctype.h. Hence we need to also include ctype.h along with including stdio.h as well as math.h. So suppose if it is a digit, then as we have know, we need to push that to a stack, and while pushing, if you observe here, I am saying s of I minus in single quote I am saying 0. The reason behind this is, now we are defining string, and as we have studied, string is nothing but a sequence of characters. But if it is a digit, then that should be an integer value, and as we know, each integer value is having ASCII defined value. Whenever we are extracting in the form of character, so it will return ASCII value of that particular character or even digit. So hence, if I subtract that with the ASCII value of 0, then I will get exact digit value. So for that purpose, I am saying push s of I minus in single quote 0. This is nothing but, instead of getting ASCII value, I want a digit value between 0 to 9. To perform or to get that exact value, I am subtracting our character value by ASCII value of 0. Suppose if it is not a digit, then it should be a operator. In that case, we know that we need to perform pop operation twice. So when I perform first pop operation, I am storing that in y, and second pop operation when I perform, the returned value will be stored in x. Based on the operator, because which s of I is not digit means it should be an operator. Based on operator, it will match either of the defined cases. And again in problem statement, it is clearly stated that we need to support plus, minus, multiplication, division, exponential operator as well as modulus operator. So now in this case, if it is plus, then we need to perform push. Before pushing the value, we need to perform addition operation on both the value x and y. Hence, if you observe, I am saying push x plus y. First it will calculate x plus y, and whatever resultant value it will get, that value will be pushed to the stack. Similarly, we are performing other operations like x minus y, x multiplication y, x division y, and power x comma y. And again here we need to include one more case, that is modulus operator. So simply say push in bracket x mod y, and then say break. At the end, we know that after evaluating or once we reach end of our postfix expression, then for loop will be terminated, and for rest of the characters, scanned character, it will follow same procedure. If it is digit, it will push directly over to a stack. If the scanned character is operator, it will first perform to pop operation. Based on the operator, it will execute respective case. It will perform that matching operation on x and y variables, and the resultant will be pushed back to a stack. This procedure will continue until and unless it reaches to the end of the postfix expression. Once we reach end of the postfix expression, the for loop will be terminated. In that case, again we know that whatever element is present in your stack, that will be the resultant of your given expression. Hence we need to perform pop. Whatever value you will pop at the end of your program, that is the resultant value for your given postfix expression. Hence, in my last printf statement, I am saying result is %d, and then I am calling pop function. As we know, pop function is returning integer value. That value is the resultant value for a given postfix expression. Again in this example, we have used push and pop functions, and these two functions are our user defined functions. And again in this example also, we are defining our user defined functions before main function. Hence it is not necessary for us to declare our function prototypes. And as we have studied numerous times the implementation of push and pop, whenever we want to push the element, first we need to increment the value of top by 1, and then we need to initialize. So hence if you observe my expression, I am doing pre-increment, and then in resultant index I am storing the value of x. Similarly in case of pop, first we need to extract value from a stack, and then we need to decrement the value of top by 1. Hence if you observe in pop function, I am returning first stack of top, that is nothing but I am returning topmost element present in your stack, and then I am performing decrement of top by 1. So that is nothing but top minus minus. This is postfix expression. I hope you have understood this program. If not, or if you have any doubt, then please call me and clarify your doubts. Thank you guys.